My name is Margery Coombs, and I'm a vertebrate paleontologist who studies fossil mammals. Mammals belong to a larger group of vertebrates called synapsids. The earliest synapsids went extinct a long time ago, but we know about them from the fossil skeletons that they left behind. Edaphosaurus, on your left, and Dicynodon, on your right, are good examples of fossil synapsids. One character that defines synapsids is the presence of an opening behind the eye on the skull called the Lateral Temporal Fenestra. This opening is easy to see on the skull of Edaphosaurus. It is much harder to see on the skull of Dicynodon because the skull of Dicynodon is not as obvious and well preserved. When you're visiting a museum, you really enjoy seeing a well-preserved specimen like that of Edaphosaurus. But skulls like that of Dicynodon also have a value, but you have to work to interpret them. One way of starting to interpret a skull like that of Dicynodon is to try to find major landmarks. We are looking at a close-up of the skull of Dicynodon. One of the first things to look for is the jaw joint. This is where the lower jaw attaches to the skull at the back of the mouth. If we go forward from the jaw joint, we can see the line of the mouth, which goes up to this point. You may have noticed that along this line you do not see any chewing teeth. This is because Dicynodon is thought not to have had any chewing teeth. Instead, its jaws were covered with a beak-like material, sort of like that in birds or turtles, that helped it to process plant food. You may also have noticed this white structure here. This actually is a tooth, a large fang-like tooth, which probably was not involved with chewing. When you see a tooth like this, you are inclined to think, well, the animal must have been a carnivore because the fang-like tooth could have been used to pierce prey. However, Dicynodon does not seem to have been a carnivore, and so the large fang-like tooth was most likely used for display, allowing it to secure more food and more mates. Moving up from the fang-like tooth is the position of the eye, also called the orbit. This orbit is filled with sediment that came into the skull after the animal died. Behind the orbit is a bony bar called the postorbital bar, and behind that is the temporal fenestra. However, it is difficult to see the lateral temporal fenestra in this view of the skull. We're now looking at these same two specimens from the hallway. Here is the skull of Edaphosaurus from the other side. You can also get a good view of the rear side or posterior side of the skull of Dicynodon. And here you can get a really nice view of the large lateral temporal fenestra right here. And here is the postorbital bar right above it. Notice that the temporal fenestra of Dicynodon is much larger than that of Edaphosaurus. The temporal fenestra tends to develop an association with jaw musculature that is used in chewing. Since Dicynodon has a larger lateral temporal fenestra, we can assume that it had larger and more complicated jaw musculature in that area. We are now in the front of the skull of Dicynodon, and I'm standing on a stool so I can see the top of the skull. When you look at the skull, you can see the postorbital bar, and behind it you can see the lateral temporal fenestra. You can also see this structure that looks sort of like a small volcano right in the middle of the top of the skull. This opening is called the pineal opening, or sometimes medial opening, because it's in the middle of the top of the skull. Modern mammals do not have a pineal opening, so it is interesting to consider what the pineal opening might have done. There are living vertebrates that do retain a pineal opening, and in them, the opening has a small medial eye present. This eye does not form an image, but it does detect light versus dark, which helps the animal keep daily rhythms and to recognize seasonal changes. So what have we learned from the skull of Dicynodon? We know that it was a large animal, that it had robust, strong jaws, but no teeth, and that it probably chewed on plant food. We know that it had a large fang that was probably used in display. We can make a reconstruction of Dicynodon that looks somewhat like the animal in this sign. We can see a rather lumbering, large animal. The group that included Dicynodon was actually very diverse and numerous in many parts of the world, but it does not appear to have lived in this area. This specimen comes from South Africa and was collected by the great vertebrate paleontologist Robert Broom. We are very happy to be able to display it here.